All right, let's talk about hyperbolas. Hyperbolas are incredibly practical. I always say that, but I just don't want you to think that we're studying something that you're never going to need in life, depending on what career you go into. Let me show you two things. If this was the sun right here, where I'm pointing, a comet could follow a hyperbolic path. We talked about how they could follow an elliptical path, and they would return over and over, but some comets follow a hyperbolic path. Some of them follow a parabolic path, like a parabola, with the sun as the focus. Now, another thing they could do, that people use hyperbolas for, is that where these two dots are, these are the foci, similar to where the ellipses were, only as you can tell it's turning outward. What they'll do is they'll put microphones there, like in a forest or something like that, and it can detect things that are walking around, and it can tell how far apart those things are, and it uses the equations of a hyperbolic path in order to do so. So, sound detection. There we go. There's just two quick things come in handy for some people that choose those careers. All right, two equations for a standard form of a parabola, and then the third random equation. Now, you will see with the parabola that it looks a lot like an ellipse in terms of the equation, but notice that right there. It's a minus, not a plus. So that causes what would normally be round and elliptical to turn outward, like you see up here at the top of your page. These, just like on an ellipse, are the foci. So that's a focus. And this is a focus. This point right here and this point right here, I'll draw arrows. These are the vertices. And this, in this particular case, this is the origin, obviously, but it's also the center. There we go. Now, obviously this looks familiar. It looks Pythagorean. It is built from the Pythagorean formula, Pythagorean theorem, but this is the placement of the foci. It looks a lot like the thing with ellipses. However, with ellipses it was minus, but now it's a plus. Okay. All of this tells you how to go through it, and I'm not going to read it to you. This will refresh your memory after I do a couple of them. And so if you're kind of stuck as we go through some examples of how to graph them, how to make equations, what to do with those equations, then you can look back up here and it will guide you through it. I do want to point out a couple things though. A is always the first one, B is always the second one. That is different from ellipses. But here is the difference, the big difference. Sometimes it starts with an X and sometimes it starts with a Y. Whichever one it starts with is the direction it opens. And I halfway lied to you right there. It's actually whichever one is positive. Whichever leading coefficient is positive. Notice that the negative is halfway through, which means because the negative is halfway through, the first one is positive. So this one would open side to side, like you see here. This one would open up and down. Both up and down. It would do both. Okay, we are going to graph these. Now, I'm going to draw some stuff on the graph that's not completely part of the hyperbola. I will do it in pencil, but the actual hyperbola itself, I will draw with an ink pen. Okay, let's just get started. In this particular case, A is 5. I think it's fairly obvious. It looks a lot like the equation of an ellipse. B is 2. And you know what? While I'm at it, I'm going to go ahead and just start writing some other stuff down. I've got a pencil in my hand, so I'm going to use it. I haven't graphed anything yet, but that's okay. C squared equals A squared plus B squared. So C squared equals 25 plus 4. So C squared equals 29, which means C is the square root of 29, and that is approximately, I don't know, it's 5 point something. So square root of 29 is 5.39, and so we'll use that in just a minute. Okay, so where am I going with this? Underneath our X, that is horizontal, we will go left and right 5. 1, 2, 3, 4, 5. And I'm going to kind of put a vertical line. You'll see where I'm going with this in a minute. 5. Okay. Underneath the Y, I'm going to put a 4. I'm going to go up and down 2. So up 2 is the square root of 4, as you know. Down 2. And based on what I've drawn so far, I'm going to draw a little box. Now, what's the purpose of this box? Alright, it's time we started talking about the actual shape of a hyperbola and where it comes from and other great big words. So, here goes. That is not the hyperbola itself. clearly, but this will guide the shape of the hyperbola. Let's slide this up for just a second. You can tell what the definition is. You know, in an ellipse, we had two foci. You don't have to draw this, but we had two foci, and this distance remained constant. If we add this piece and this piece, it remained constant. Well, now here's the tricky part. If we wanted to find that point right there from one focus and the other focus, and we subtract these two distances, it'll be a constant. Here we would add these two and it would be constant. Here we subtract them and it's a constant. So it completely takes everything and turns it inside out. Well, not only does it turn it inside out, it creates asymptotes. It's a word you've heard before, but what it means is, and this is the most simple high school definition of it. It does get more complicated. But an asymptote is a line, and you've seen this before, I think, where it will approach but never cross. Now, again, when you get into some higher mathematics in college, they're going to contradict what I just told you, and that's okay. But for our definition now, basically, it will approach this dotted line, and I can draw this thing down forever, but it will never actually cross it. It gets closer and closer and closer, but never actually touches or crosses. It's really hard to do with your hands on a video. Okay, so here's our asymptotes. Asymptotes. You know what? I just mispronounced that. Asymptotes. It's not asymptotes. There's one asymptote. Here is the other asymptote. By the way, I didn't mention this, but it kind of goes without saying. The center is at 0, 0, and it's at 0, 0 here, and here as well. All right. This one opens left and right because it has a leading coefficient that is x, and the x is positive. This is a vertex. This is your other vertex, and it's going to open like that and like that. There we go. It's going to get really close to these lines but never actually cross them. How perfect does it have to be? Not very, because I can't draw it very well myself. It gets really close but never actually touches or crosses them. It's never going to jump across there. So here's what we know. I'm going to write down some stuff. Oh man, you know, that was the actual answer. I said I'd do that in ink, and I didn't. I did it with a pencil. I had the pencil in my hand. Here we go. Here's the actual answer. There we go. Whoops, I think I crossed that line. There we go. I'm going to write some stuff down. I think I wrote on my desk. I'm going to write some stuff down that it didn't ask for, but it's going to help us kind of explain things. We know where the center is. Center's at 0, 0. We also know that the vertices are there and there. And those two places are at positive 5, 0 and negative 5, 0. I'm going to start writing it a little bit differently. I'm going to call it plus and minus 5, 0. That's perfectly okay. You can do that. Now, we also need to find out where the foci are, and the foci are going to be on what's called the transverse axis, and that basically means the direction it's opening. So the transverse axis is horizontal. If it was like this one, it would be vertical. That'll become clear in a minute. Let's put the foci down 5.39 units away from the center. So 5 and then a little bit more. So there's one focus, 5 and then a little more, and there's the other focus. Just a little bit beyond the vertex. I've cluttered it up over here. It's kind of hard to see. So where are my foci? I'm glad you asked. They're at plus and minus. I'm gonna be precise with it. Square root of 29, 0. You can call it 5.39 or 5.4. That's okay. Okay, one more thing it asked us to do is to find the equation for the asymptote. So I need to know what the equation of that line is and what the equation of that line is, and really it is not that hard. I'm going to write it in red just because I want it to stand out for some reason. This line right here can be written in slope-intercept form because it's a line. I mean, you know that. So y equals a line through the origin with a slope of up to over 5. You got this. up to over 5, that would be 2/5 x, plus 0, because that's the y-intercept. So the equation of this line is 2/5 x. Well, I need the equation for both asymptotes, and the other one is the exact same equation, only instead of being positive 2/5, it's negative 2/5. So I'm going to just do like I did on that last little piece and put them both as 1. So I have two equations of a line right here, y equals plus and minus 2/5 x. There's the first problem. Let's move on to the second one. The second problem, the second hyperbola that we are going to graph, opens up and down because the y is the positive component, which generally means it's first. So we're going to have it open up and down. The a value is 3. Unlike with ellipses, it doesn't have to be the big one. But really, it's going to be kind of common sense. Underneath the y, we'll move up and down 3. 1, 2, 3. 1, 2, 3. Underneath the x, there's a 4 that's squared, so we're going to move right 4, and we're going to move left 4. And here's my box. I might do things in a different order this time. By the way, I've already mentioned it before, but this one is centered at 0, 0. So for what it matters, I'm going to come over here and I'm going to go ahead and write center 0, 0. Oh, let's go ahead and write some other stuff. Vertices, foci. Oh man, why'd I do that? I probably should have just written it as one coordinate. Oh well, no big deal. We'll get over it. Let's draw that. That's going to be one asymptote. In a minute when we draw that, it's going to approach that line but never actually cross it. There we go. So, does this one open up and down or left and right? We've already discussed it, but here it is again. The y is positive and first, so therefore it's going to open up and down. So it starts here. Oh, those are the vertices, I should say. So it's actually at 0, 3 and 0, negative 3, so I don't need that second set of parentheses. You can write it as two separate coordinates if you like. I just choose not to. And I'm wasting my whiteout. There we go. But it looks like this. No, it doesn't have to be perfect. But it gets really close to those lines and never crosses them. Doesn't have to be perfect. Okay. So that's what we have so far. Again, vertices are at 0, 3 and 0, negative 3. Where are my foci? Well, I don't know. I do know I only need one set of coordinates for it. Let's come up here and write some stuff down. C squared equals A squared plus B squared. A is 3, so that makes it 9 plus 4 squared. 16 is 25. That's C squared. So C is 5, which means this. For my foci, I'm going to move 5 up and 5 down. But Mr. Reader, on the last one, you went left and right. Yeah, whatever. This thing opens up and down, so my foci better be inside there. Just like in a parabola, the parabola would eat the focus. It was always facing in that direction. It's the same thing here. We're going to have one branch of the hyperbola facing that one, or opening towards that one, and the other branch will be opening that one, towards that one. It's up 5 and down 5. So my foci are at 0, plus and minus 5. 0, 5, and 0, negative 5. Okay, last little piece on this problem. Y equals, well, I need to know what the equation of this line is. I'm going to actually color it in green just to make it a little bolder on the video for you. I need to know the equation of this line. This is a line, obviously. Because it is a line, I can write it in slope-intercept form. For slope-intercept form, I need a slope like 3/4. And I need a y-intercept, which is 0, so I'll leave it off. But the other line is at 0 as well, but also has a slope of 3/4, only it is negative. One line went up, the other line went down. So those are your two equations right there. The next problem is not nearly as hard as it looks, nor is that one. Let's keep moving. If it's a hyperbola, the equation in standard form better equal 1, and it doesn't. So let's make it equal 1. We're going to divide, my pen would work, we're going to divide by 100. When we divide by 100, that will give us the 1 that we need right there. This reduces, so we have y squared over 4. This reduces, we have x squared over 4, and there's a minus in the middle. It is that minus that makes this thing a hyperbola, and we are good to go. We are ready to go. So, this thing opens left and right because it starts with an x. It is going to have a square box. We can tell that because the numbers are the same. So let's go ahead and draw our box. Left and right 2. Left 2, right 2. Up and down 2. Up 2, down 2. There's one asymptote. There's the other. When you're drawing your actual hyperbola, don't you cross those things. Don't you do it. You know what I feel like doing right now? I feel like jumping to the end. Y equals what? What are the equations of these lines? Again, it goes through the origin, which makes it really, really easy. Because I know the center's at 0, 0. I don't have to list this stuff. The directions didn't tell me to, but it kind of helps me explain it. But the center's at 0, 0, so my y-intercept is 0. My slope is 2 over 2. Well, let's be realistic. What's 2 over 2? 2 divided by 2 is 1. So it is 1x. And it's also negative 1x. So it's plus and minus 1x. Already got the last part done. Let's move on and do some of the other stuff. Center, 0, 0, obviously. Vertices. And foci. Okay. I'm going to use a blue pen. Opens left and right. There's a vertex. There's a vertex. Let's come over here and write it. One of the vertices was at negative 2, 0. The other one was at positive 2, 0. Where are the foci? I don't know yet. It looks awfully pointy. It's supposed to be a little more rounded, but oh well. I think I just wrote on my desk again. No, it's good. Well, a little bit. It'll be alright. It'll come out. Brillo pad, get it off. Okay, I need to know where my foci are. I'm going to scribble with a pencil down here. C squared equals A squared plus B squared. That would be 4 plus 4. I know what that is. That is 8. So C is the square root of 8, which is 2 squared of 2, which is approximately 2.4, no, 2.8, I don't know. I'm trying to guess. Good grief. How about I just type it in the calculator? Yeah. 2.83 is close enough. Which means when I'm graphing my foci, I'm going to go 2.8 this way and 2.8 that way, which means my foci are at plus and minus 2.83. I'm going to write it like this. I want to be precise with it. If you want to use a decimal, that's okay. There we go. I'm going to do this last one, and then we'll break into a separate video. We'll do the back part in a separate video. Okay, is it a hyperbola? Yes. Is it in standard form? No, it's not. It's got to equal 1, so we're going to divide it by 4. We'll divide you by 4, and we'll divide you by 4. And when we do that, we have the 1 that we wanted on the right. We have y squared over 1. I'm going to go ahead and put it over 1. And we have x squared over 4. And good grief, let's just go ahead and start writing some stuff. We know where the center is. We're about to find out where the vertices are. And we're about to find out where the foci are. Center's at 0, 0. That changes when we get to the back on one of the problems. But for now, we'll just leave it at 0, 0. Alright. We will go we will go under the X, left and right 2. Left 2, right 2. Under the Y, we'll go up and down 1. This one's kind of a flat box compared to the last one. And it looks like that. Isn't that cute? Not really. Okay, does this one open left and right or up and down? You notice I just did up and down backwards. How about this? Up and down. Which one is it? Well, it starts with the X, and that is the positive component, the positive term. So we are going to go in the X direction, so left and right. So it's kind of rounded, and it does like that. That actually looks more like a V than a hyperbola, but oh well. There we go. So my vertices are here and here. That is -2, 0, and +2, 0. So that's plus and minus 2, 0. Foci, I don't know yet. Let's grab a pencil and figure it out real quick. C squared equals A squared plus B squared. So 4 plus 1, obviously that's 5. So C is the square root of 5. Square root of 5 is approximately 2.24. Approximately. So we're going to go 2, and then a little more, 2, and then a little more. Now I had to go a lot more because it's kind of hard to tell. There it is. Alright, foci are at that red dot, comma 0, and that red dot, comma 0. That was horizontal movement of that much, square root of 5. So plus or minus square root of 5, comma 0. We're almost done. Almost done. Let's write an equation. Or 2. We can write 2 in 1. Since it goes through the origin, the y-intercept is 0. Here's the part I never write. If I wanted to, I could put plus 0. I should say 0. Or plus 0. Or plus 0. Or plus 0. But I don't have to. But I know I have an x. For my slope, I'd rise 1 and run 2. That would be 1/2. Well, you know what? We've said this before. There has to be a positive component and a negative, and it's the exact same thing. I'd go down 1 and over 2, so it's plus and minus 1/2. Alright, in the next video we are going to do the backside, and it will be fun.